and time. So we're going to be able to calculate average speed, distance and time, and to be able to convert between the metric measures of speed. Okay, so before we start then, let's just check again our prior knowledge. So we need to be able to convert between the metric units of length. So 1 kilometre is equal to 1,000 metres, 1 metre is equal to 100 centimetres, and 1 centimetre is equal to 10 millimetres. You also need to be able to convert between measures of time. So 1 hour is 60 minutes, a quarter of an hour is 0.25 hours, which is 15 minutes, half an hour, 0.5 hours, 30 minutes, and most importantly, to convert any amount of minutes into hours, we do the number of minutes divided by 60. So we're dividing by 60 because there are 60 minutes in each hour. We should also know the number of minutes and seconds in an hour. That makes it much easier to do some of these calculations. So 1 hour is 60 minutes, 1 minute is 60 seconds, therefore 1 hour is 3,600 seconds. So if there are 60 minutes to an hour and 60 seconds to a minute, 60 times 60 is 3,600, so there must be 3,600 seconds in 1 hour. If you need to, pause the video now, make a note of those, or go back and do any of the previous lessons if you're not sure about any of those things. Okay. So we're continuing with our theme of compound measures then. So speed is also a compound measure. Now you should have seen speed, distance and time before. You will have done speed, distance, time graphs when we did the unit on real life graphs. Okay, so you will hopefully be quite familiar with this triangle. If not, it's a good idea to draw it out. So again, the way these triangles work then, if things are next to each other, they're multiplied, above and below they become divided. So if I want to find the distance, if I cover up distance, I'm left with speed and time next to each other, so it's the speed multiplied by the time. Now our units for distance, we have an imperial unit for distance of miles, and we have our metric units of kilometres or metres. So we're not just going to be using metric, we're going to also be using miles predominantly, because we're in England and all of our road signs are in miles, but we also need to make sure we know about kilometres and metres as well. Okay, if I want to find the speed then, if I cover up the speed, I have distance over time, so that's distance divided by time. The units for that, if we're using miles, then we'll do miles per hour, or we could have kilometres per hour, or we would have metres per second. So they're the normal units for measuring speed. Finally, for time then, if I want to find the time, we'll cover up time, we're left with distance over speed, so that's distance divided by speed, and our units of time are usually hours or minutes or seconds. Sorry, I missed off seconds from the end there, but hours or minutes or seconds there. Okay, make sure you're happy with that before you move on. If you need to write down those formulae, please do that now. Okay then, so just to check a bit of understanding, we should be quite familiar with distance. If we've got a car that travels at 70 miles per hour, that means it's going to do 70 miles for every hour of time that passes. How far will it travel in 2 hours, half an hour and 5 hours? So just pause the video and give yourself sort of 30 seconds to have a go at answering those questions. Okay, well if it's travelling at 70 miles per hour, so 70 miles for 1 hour, and we do 2 hours, that would be 2 lots of 70. So 70 times 2, we would travel 140 miles. If we're only going to travel for half an hour and it does 70 miles in 1 hour, then we need half of that distance. So we can either divide by 2 or multiply by 0.5, remembering 0.5 is the same as half an hour. So that's 35 miles. And if we were travelling for 5 hours, that would be 70 times 5. We would do 350 miles. Okay. We're now going to have a look at time then and just make sure we can convert between the different times. So again, pause the video for a moment, have a go at seeing if you can convert those times from hours and minutes into just decimalised hours. All right, so 2 hours and 30 minutes. So remember, 30 minutes is half an hour. Half as a decimal is 0.5. So that's 2.5 hours. If we weren't sure, we would do 2 hours. There's our whole hours. And remember, change any number of minutes into hours. It's the number of minutes divided by 60. So that's 2 hours and 30 sixtieths. Now, there are different ways we can put that into our calculator if we want to work that out. So this is the normal face of your calculator. So if you're using a Casio calculator, as most of you will have, this is what you should see. So if I want to type this into my calculator, remember this is a mixed number fraction. So if I want to put the whole thing in, I'm going to have to press the Shift key up here first, and then the fraction key. So you can see we have a normal fraction, and the yellow one above is our mixed number, where we have a whole number and a fraction. So we can't just type in a whole number and then press the fraction button. It doesn't work the same way. So if I want to put in a mixed number, Shift, then the fraction button, and we can put the 2 into the box, and the 30 and the 60. Otherwise, if you want to just use the fraction button, then you just do that for the 30 over 60. So you'd keep the 2, put in 30 over 60, and that will give you 0.5. And we can then write 2.5 hours. Okay, so some different ways of using that. Just make sure you're happy with how you want to see that on your calculator. Okay, 1 hour and 15 minutes then. We might already know that 15 minutes is quarter of an hour, and a quarter as a decimal is 0.25. So that would be 1.25. Again, if we're not sure, we can do the 15 minutes out of 60. So again, either putting in as a whole mixed number to get the whole answer, or just putting in the fraction to get the decimal part. Finally then, 4 hours and 20 minutes. So 20 minutes is a third of an hour. A third as a decimal is 0.3 recurring. So we get 4.3 recurring. So remember, this little dot is recurring. It means it's going to say 4.3333 continuously. Again, if you type that into your calculator, some calculators will give you as 4.3 with the recurring dots. Some might give you 4 and then lots of 3s afterwards. Be aware of this little recurring dot though. Sometimes when people are looking at the calculator, they don't notice that there's a small dot above a number. If there is, that's telling us it's recurring. It's really important that we write that down and don't just ignore it. Okay, 4.3 is different to 4.3 recurring. Okay. Now then, we're going to have a go at converting from hours back to hours and minutes, because quite often we need to use hours as decimals for our calculations, but we want our final answer in hours and minutes. So again, pause the video, have a go, use your calculator if you need to convert those back to hours and minutes. Okay. So to convert them back to hours and minutes then, hopefully it's fairly clear that we don't just write the decimal as the number of minutes. It's not 1 hour and 75 minutes. There aren't 75 minutes in an hour in the first place, so that definitely cannot be the answer. So remember, that's 0.75 of an hour. So we have 1 whole hour, the number 1 here, and 0.75 of an hour. To change from hours back to minutes, we do the opposite. So here we divided to change minutes into hours. So here we're going to do the opposite, which is multiplying. So 0.75 times 60 is 45. So we have our 1 hour and our 45 minutes. So again for this one, 2.30 hours. That's not 2.5 hours. It's not 2 hours and 30 minutes. So again, we're going to put that in 2 hours, then the 0.30 times 60 to change it from hours back to minutes, and that comes to 18. So we have 2 hours and 18 minutes. Now when we're putting this one into our calculator, we've got our 4, so that's our 4 hours. So we've got 4 hours and 0.6 recurring minutes. When you put this into your calculator does have a recurring decimal button. So again, we would need to press Shift first, and then we're going to press this button here, our X squared button. Above our X squared button, we've got a square with a little dot. That's telling us we can put in a recurring number. So we would press 0 point, then Shift, and this button here, and it will bring up a little box with a dot above, and we can put the 6 in the box, and then we can times that by 60. Okay, that will give us our answer of 49 minutes here. So 4 hours, sorry, again, that's better. So that's 4 hours and 49 minutes there. Okay, so be careful with that recurring decimal. If you don't have a recurring decimal button, then you can simply put in 0.6 and make a whole line of sixes. So 0.6666666, quite a few sixes, and that will give you as accurate an answer as possible. Okay, so hopefully now we've practiced a little bit about making sure our distance and time are in the right units. We can move on to having a look at how we're going to use those. So here we are then, we've got some questions involving speed, distance and time. So the first one, the distance from Cardiff to Leeds is 335 kilometres. Reece drives from Cardiff to Leeds in 6 hours and 15 minutes. Work out his average speed. So first of all then we'll start with our speed, distance, time triangle. We're asked to find his speed, so we're going to cover up speed. So we need to do his distance divided by his time. Now we can see his distance there, 335 kilometres, and we've got our time in hours and minutes. Now we need the time to just be in hours. So we're going to change 6 hours and 15 minutes into hours, remembering 15 minutes, quarter of an hour, quarter is 0.25. So we will have 6.25. So 335 our distance divided by 6.25 our time in hours gives us 53.6 kilometres per hour. Okay, our second question then. So Michael decides to go for a cycle ride. He rides a distance of 80 kilometres at an average speed of 24 kilometres per hour. Work out how long Michael's ride takes. So again, let's start with our triangle. This time we were asked to work out the time. So we're left with distance divided by speed. So his distance of 80 kilometres, his speed is 24 kilometres per hour. Okay, so 80 divided by 24 gives us 3.3 recurring hours. So my calculator gave me this little dot above this 3. So that's 3.33333, etc. So I need to change that now into hours and minutes. We don't usually give a time like this in decimalised hours. So we've got our 3 hours, our 0.3 recurring. So we're going to use our recurring button again in our calculator, times 60 to change from hours to minutes. Gives us 3 hours and 20 minutes. Finally then, we've got an aeroplane travels for 3 hours and 20 minutes at an average speed of 600 miles per hour. How far has it travelled? So this time we're asked to find the distance. So we know the speed is 600 miles per hour and we've got our time in hours and minutes. So again, we're going to have to convert our time to hours. So that's 3 hours and 20 divided by 60. Okay, 20 minutes, a third of an hour, so that's 0.3 recurring. Okay, so if we put it in as 20 over 60, that saves us putting in the recurring button, or we can put in our 3.3 recurring, and we get 2,000 miles. Alright, so we're using the triangle to help us to decide if we're multiplying or dividing, and we're making sure that we've got our values in the correct units before we do our calculations. Okay, pause the video now then, have a go at those, read through them carefully, use the triangle, so it's a good idea to draw the triangle and you can just simply place your finger over the one that you're going to find to see which ones are left. Okay, let's have a look at the answers for these then. So for the first one, we're working out Jane's speed and we're told to give the answer to 1 decimal place. So we should have 200 divided by 21.4, which is 9.4 metres per second to 1 decimal place. For number 2, we're going to do 310, so it's distance divided by 5, the time, which gives us 62 miles per hour. For number 3, we're working out the time, so we're doing our distance divided by our speed, which gives us 6 hours. For number 4, we're working out the distance, so we're going to do our speed times our time. So again, we've got to change that time of 3.5 hours into our decimal. That gives us 26.6 miles, so he's definitely run his marathon. And finally then, we're asked to find out the speed in miles per hour. So we've been given our time is 15 minutes, so we need to change that to hours, so 0.25 hours. And we've been given our distance, so distance divided by time, which gives us 96 miles per hour. Pause the video if you need to and check through those answers. So now we're going to have a look then at average speed. So sometimes, rather than just being asked to find the speed, the distance all the time, we're asked to find the average speed for an entire journey. So to find the average speed, we need to do the total distance divided by the total time. So an example then, car travels the first 35 kilometres of his journey in 45 minutes. He then travels the last 65 kilometres in 1.5 hours. What's the average speed for the whole journey in kilometres per hour? So first of all then we need to find his total distance. So his total distance, he did 35 kilometres to start with, followed by 65 kilometres. So that gives us 100 kilometres. So again, whenever you're doing these longer problems, making sure you set out the work nice and clearly so you can see which answers you've got from where. We now need to find the total time. So his total time then, so 45 minutes we need to change into hours. So 45 divided by 60 plus his 1.5 hours, so 1.5 hours there. That gives us a total of 2.25 hours, so 2.25 hours. Now we can find the average speed then, so we do the total distance divided by the total time. His average speed, 44.4 kilometres per hour to 1 decimal place. Okay, let's have a look at a second example then. So on Monday, Ravi drives for 3 hours at an average speed of 48 kilometres per hour. On Tuesday, he drives 200 kilometres at an average speed of 50 kilometres per hour. What is his average speed for the 2 days to the nearest kilometre per hour? So again, let's start off then by finding the total distance. Now we don't yet know his distance on Monday, so we're going to have to find out his distance on Monday. So remember, to find distance, it is speed times time. So on Monday, our speed was 48 times a time of 3 hours, 144 kilometres. Again, use your triangle to help you to make sure whether you're multiplying or dividing. On Tuesday, we were told his distance was 200 kilometres, so his total distance is 144 plus 200, which is 344 kilometres. Now we need to find his total time. So we were told the time on Monday was 3 hours, but we haven't been given the time for Tuesday, so we're going to have to find the time for Tuesday. So Monday, we had our 3 hours. On Tuesday, we were given his distance and his speed. So to do time, remember it's distance divided by speed. 200 divided by 50 gives us 4 hours. So his total time, 3 plus 4, was 7 hours. Now we've worked out, again, the total distance and the total time, we can find his average speed. So that's our total distance divided by our total time, which is 49 kilometres per hour. So if we're not given all of the information we need, we may need to do a calculation first to get that bit of information. But again, breaking down your problem into small sections so that you can see which information you have and which information you need will really help you with these problem-solving style questions. Okay, so your turn then. Dom cycles 44.5 kilometres at an average speed of 15.5 kilometres per hour. He then cycles 0.5 kilometres at an average speed of 25 kilometers per hour. What is his average speed for the whole journey? So I've given you again the formula at the top here. Remember, average speed is total distance divided by its total time. Pause the video and have a go at that now. Okay, so let's have a look at our solution for that one then. So first of all, we need his total distance. So we were told his total distance, his distance for the first part was 44.5 and his distance for the second part was 0.5, both in kilometres. So that gives us 45 kilometres. We now need his total time. We've not been given the time for either part of the journey, so we're going to have to work out the time for each part of the journey. So time is distance divided by speed. So for the first part of the journey, 44.5 kilometres divided by 15.5 kilometres per hour gives us 2.8709 hours. Now, the dots are there to show that that number continued. Please write down at least 4 decimal places of a number if you're going to be using it again in a further calculation. The second part then, we have his distance of 0.5 divided by his speed of 25, which gave us 0.02 hours. So his total time is our 2.8709. If you've left the whole number in your calculator, then you can use that, but if not, at least 4 decimal places, plus 0.02, which gives us 2.8909 hours. So to find his average speed, we've got our total distance divided by our total time, which gives us 15.6 kilometres per hour to the nearest 1 decimal place. Okay, we're now going to have a look then at how we convert our speeds. So we need to be able to convert speed from kilometres per hour to metres per second and from metres per second back to kilometres per hour. Now when we're converting, we do this in 3 steps. I'm going to go through those steps with you. Step 1, we're going to convert the kilometres into metres. So we've got 120 kilometres and we want it into metres. So to convert from kilometres to metres, I'll put this little diagram over here to help you. So going from kilometres to metres, we multiply by 1,000. If I want to go from metres to kilometres, we divide by 1,000. There are 1,000 metres per kilometre. So 120 kilometres, 120 times 1,000 is 120,000 metres. Step 2 is to do the bottom units. We need to change the hours into seconds. To convert 1 hour into seconds, 1 hour is 3,600 seconds. So we had that in our prior knowledge at the start of this video. So again, if you've forgotten, the reason that's 3,600 seconds there are 60 minutes in an hour and 60 seconds in a minute. So 60 times 60 is 3,600 seconds. So again, put a little diagram there just to remind you. So now we've converted those, we can put them back together. So our last step is to divide them. Remember, this line between is a division. So we're going to do our metres divided by our seconds, because we want metres per second, metres divided by seconds, and that gives us 33 metres per second to the nearest whole number. Okay, another way of looking at this then with the diagram here is I've got 120 kilometres per hour. So per hour means for 1 hour. So 120 kilometres for 1 hour. I changed the kilometres into metres on the top line. I've changed the hour into seconds on the bottom line, and then divided the 2 answers to get my answer. So a short way of writing all of this out is at the bottom here. So again, if you need to, pause the video and make a note of those steps and how to write that down. Okay, so now we've converted kilometres per hour into metres per second, we need to go the other way. So we're going to convert 10 metres per second into kilometres per hour. So we're going to follow the same steps. We're going to start by converting the metres to kilometres. So 10 metres into kilometres. So remember, if I want to go from meters to kilometers, I need to divide it by 1,000. So we're going to do 10 divided by 1,000, which is 0.01 kilometers. We're then going to do the bottom, so we're going to change the seconds into hours. So we do one unit and then the other unit. So 1 second, to go from seconds to hours, we divide by 3,600. 1 divided by 3,600 is 0.000277, and that 7 is a recurring 7. So again, you could use your recurring dot if you've got that on your calculator, or just put lots of 7s after that in your calculator there. And then we do our division. So we're going to divide our kilometres by our hours to get kilometres per hour, and we get 36 kilometres per hour. So again, another way of showing that, we've got 10 metres per 1 second. We're going to change the metres to kilometres. We're going to change the seconds to hours, and then we divide our answer to get our 36 kilometres per hour. Again, pause the video if you need to and make a note of that example. Okay, so now it's your turn. So you've got 5 questions there, either changing from kilometres per hour to metres per second, or from metres per second to kilometres per hour. So use your notes to help you give all your answers to 1 decimal place. Pause the video and have a go now in your maths book. Okay, let's have a look then at the solutions for those. So for our first one, we have 22.2 metres per second, then 55.5 metres per second, 360 kilometres per hour, 900 kilometres per hour, and 8.3 metres per second. Okay, make sure you've checked through those then. If you've made any mistakes there, just go back and have a look. Use those diagrams to help you with your conversions if you need to. Okay, finally then today, let's have a look at when we might need to use this. So a jet aircraft has a cruising speed of 250 metres per second. What is its speed in kilometres per hour? So we're going to start off, we've got 200 metres per 1 second. So there we are, my 200 metres per 1 second. I'm going to start off by changing the top line, so I'm going to change metres to kilometres. So to change metres to kilometres, we divide by 1,000. That gives us 0.25 kilometres. Now we're going to do the bottom line, then we're going to change 1 second into hours. So we're going to divide by 3,600. That gives us our 0.000277 recurring. And we're going to divide those two numbers, and that gives us 900 kilometres per hour. Okay, so pretty fast for a jet plane. Alright, well, thank you for working through that lesson. I hope that's been useful to you. Click on the link to move on to the next lesson, and hopefully see you again next time.